Some vehicles aren't built for speed, style, or comfort. They're built to conquer the impossible. From frozen tundras to scorching deserts, these 4x4s were engineered to survive and dominate where others fail. Every bolt, axle, and drivetrain was designed with a single purpose: reliability in the harshest conditions. Join us as we uncover 10 obscure industrial 4x4s that shaped the future of off-road engineering. Number 10. Kaiser Jeep M715. Developed in the late 1960s, the Kaiser Jeep M715 was America's attempt to modernize military transport trucks for light-duty operations. Engineers focused on combining off-road mobility with a payload capacity suitable for logistics and troop transport. The M715 was based on the civilian Jeep Gladiator, but heavily reinforced for military use. Four-wheel drive with a 2-speed transfer case allowed it to tackle mud, sand, and rugged terrain. Its Lada frame chassis provided durability under heavy loads and harsh conditions. Short overhangs and high ground clearance improved obstacle negotiation and maneuverability. All mechanical components were designed for field maintenance, minimizing downtime during operations. The M715 quickly became a staple in US military convoys and Allied forces overseas. Its diesel engine option offered reliability and torque for demanding off-road conditions. Even in remote regions, operators could maintain and repair the vehicle without specialized equipment. The suspension system featured reinforced leaf springs front and rear to manage heavy payloads. Portal hubs and heavy-duty axles improved clearance and traction in off-road situations. Transmission and differential systems were oversized to endure prolonged stress and repeated use. Hydraulic brakes and upgraded steering components ensured control under fully loaded conditions. The vehicle's utilitarian interior emphasized functionality and durability over comfort. Engine placement and weight distribution were optimized for stability on uneven terrain. Field tests demonstrated the M715's ability to operate in jungles, deserts, and mountainous regions without failure. This combination of durability, versatility, and simplicity made it a reliable workhorse for military logistics. Its modular design allowed for troop, cargo, or communications variants. Even today, surviving, M715 units remain operational, a testament to its engineering foresight. The Kaiser Jeep M715 influenced future military light trucks and tactical transport vehicles. Design philosophies emphasizing simplicity, serviceability, and durability were carried into subsequent military 4x4s. Operators valued a vehicle that could perform in diverse climates and terrains while carrying heavy loads. The M715 demonstrated that military transport trucks could combine mobility, payload, and reliability effectively. Its legacy remains in the continued evolution of tactical and industrial 4x4s worldwide. Few vehicles of its era achieved the same balance of field readiness, ruggedness, and practicality. For engineers, military planners, and off-road enthusiasts, the Kaiser Jeep M715 stands as a milestone in industrial 4x4 design. Number 9. Land Rover Series 2. Developed as a rugged utility vehicle, the Land Rover Series 2 refined the original Series 1, design with enhanced capability and durability. Engineers focused on improving chassis, rigidity, suspension travel, and load capacity for agricultural and industrial applications. Its ladder frame design and lightweight aluminum body allowed it to tackle harsh terrain without excessive weight. Permanent four-wheel drive with a 2-speed transfer case gave operators flexibility in extreme conditions. Short overhangs and high ground clearance allowed it to cross streams, rocks, and muddy tracks with ease. Front and rear live axles provided reliable articulation over uneven terrain. Even in the most remote locations, the vehicle could be repaired with basic tools and minimal parts. The Series 2 became a favorite for farmers, explorers, and military units across Europe and Africa. Engine choices balanced torque for off-road use and efficiency for long-distance travel. Its utilitarian design prioritized function over aesthetics, yet the vehicle's simplicity proved timeless. Body modifications and optional equipment allowed adaptation for forestry, expedition, and industrial roles. Suspension tuning improved wheel contact and ride comfort over rough roads and off-road obstacles. Braking and steering systems were upgraded to handle increased payload and repeated off-road use. Durability testing ensured the Series 2 could withstand both extreme climates and long-term use. Its modular construction enabled field modifications for specialized tasks. Over decades of service, it proved reliable in environments ranging from desert expanses to mountainous regions. The Land Rover Series 2's engineering philosophy influenced later utility and SUV designs worldwide. Its balance of simplicity, reliability, and adaptability set a standard for future off-road vehicles. Even today, collectors and off-road enthusiasts study its design for lessons in functional engineering. The Series 2's legacy continues in modern Land Rover vehicles and utility 4x4s around the globe. Innovations such as lightweight aluminum bodies and flexible drivetrain layouts informed future industrial vehicle design. Operators valued a vehicle that could carry cargo, tow equipment, and navigate the toughest terrain. Its robustness made it a preferred choice for exploration, logging, and military transport. The vehicle's simple, maintainable systems ensured long-term operational readiness. Few vehicles combine durability, versatility, and practicality as effectively as the Series 2. For engineers and adventurers alike, the Land Rover Series 2 remains a benchmark in 4x4 design and industrial utility. Number 8. Mitsubishi Pajero. Launched in the early 1980s, the Pajero was Mitsubishi's answer to the growing demand for capable off-road SUVs worldwide. Engineers aimed to blend rugged off-road performance with on-road comfort, something few competitors managed at the time. Its body-on-frame construction provided durability and torsional strength over rough terrain. Four-wheel drive with selectable high and low ranges allowed operators to tackle diverse landscapes. Independent front suspension and coil springs improved wheel articulation and ride quality. A short wheelbase enabled sharp maneuvering in tight trails, while overhangs were minimized for obstacle clearance. The Pajero quickly became known for its reliability in deserts, jungles, and mountainous regions. Engine choices were designed for torque delivery and long-term endurance rather than raw speed. Every component emphasized serviceability, making it popular in remote areas with limited access to maintenance facilities. The Pajero established itself as one of the most balanced industrial 4x4s of the 1980s and 1990s. Drivetrain design emphasized simplicity and robustness, with permanent 4WD complemented by locking differentials. Power distribution was optimized for traction across sand, mud, snow, and rocks. Chassis reinforcements allowed heavier payloads without sacrificing stability. Suspension systems absorbed shocks while maintaining chassis integrity over rough terrain. Portal hubs and high ground clearance improved approach, breakover, and departure angles. Transmission systems were engineered for longevity under repeated stress. Interior layout was utilitarian, emphasizing durability while providing sufficient operator comfort. The Pajero's combination of capability and comfort made it appealing for both military and civilian operators. Minor design revisions over the years improved drivability and maintainability without compromising its off-road DNA. Its impact is still visible in modern SUVs and off-road vehicles. Design principles pioneered in the Pajero influenced suspension and drivetrain layouts in later 4x4s. The concept that a vehicle could perform equally well off-road and on-road gained mainstream acceptance. Operators appreciated a vehicle that could carry loads, traverse difficult terrain, and remain serviceable under harsh conditions. Its blend of engineering foresight and practical design set a benchmark for compact industrial 4x4s. Few vehicles have balanced versatility, endurance, and comfort as successfully as the Pajero. For engineers, operators, and enthusiasts alike, The Mitsubishi Pajero stands as a timeless example of purposeful 4x4 design. Number 7. Praga V3S. Developed in post-war Czechoslovakia, the Praga V3S was designed as a rugged, all-terrain transport truck for military and industrial use. Engineers prioritized simplicity, reliability, and adaptability over comfort or speed. The vehicle's short wheelbase and high ground clearance allowed it to operate in forests, mountains, and unpaved roads. Its modular chassis could accommodate troop transport, cargo beds, or specialized equipment. Permanent four-wheel drive ensured traction across mud, snow, and rocky terrain. Differential locks and low-range gearing enhanced its ability to conquer steep inclines and difficult ground. Every component was designed to be serviceable in the field, often without specialized tools. The V3S quickly became a backbone for military logistics, bridging gaps in remote and rugged areas. Civilian operators, particularly in forestry and construction, also adopted it for its durability. Even under extreme loads, the drivetrain proved nearly indestructible. At its core, the V3S employed a simple but robust inline-six diesel engine. This power plant delivered sufficient torque for steep climbs and heavy cargo without overcomplicating maintenance. Solid axles front and rear provided consistent wheel articulation and strength. Portal hubs increased ground clearance while keeping components protected. The Lada frame chassis allowed various body configurations for military or industrial roles. Mechanical simplicity minimized failure points and allowed rapid field repairs. Suspension components were designed to absorb rough terrain without transferring stress to the chassis. Its low-tech but highly reliable systems made it a favorite among operators in remote regions. Hydraulic and braking systems were reinforced to handle both off-road and loaded highway conditions. These design choices made the Praga V3S one of the most enduring and versatile trucks of its era. The V3S's influence is evident in both military and civilian heavy-duty vehicles. Its modularity inspired later multi-role 4x4 trucks across Europe. Engineers studied its durability as a benchmark for long-term field performance. The balance of mobility, payload, and simplicity informed design philosophies for decades. Many modern off-road trucks echo its robust mechanical layout. Industrial operators appreciated that the vehicle could operate continuously under harsh conditions. Collectors and military historians now regard the V3S as a milestone in engineering. Few trucks have combined such versatility, resilience, and simplicity in a single platform. Number 6. Toyota Mega Cruiser. Conceived as Japan's answer to heavy-duty military and industrial 4x4s, the Mega Cruiser was built for environments where ordinary trucks failed. Toyota engineers aimed to combine extreme off-road capability with modern vehicle comfort for long-range operations. Unlike typical civilian SUVs, it prioritized payload, towing capacity, and cross-country mobility above all else. The vehicle's massive frame and wide stance allowed it to traverse rough terrain while carrying substantial loads. Four-wheel drive was permanently engaged, with a locking center differential for maximum traction. Portal axle design provided exceptional ground clearance without compromising stability. Steering geometry and suspension travel were calibrated to handle both off-road obstacles and highway speeds. Its design addressed the logistical needs of military units while maintaining usability for industrial operators. Engineers integrated modular components for easier maintenance in remote or rugged locations. The vehicle's robust drivetrain could endure years of intensive service under harsh conditions. Toyota's approach was methodical, testing the Mega Cruiser in deserts, snowfields, and mountainous regions. At its core, the Mega Cruiser relied on a full-time four-wheel drive system paired with heavy-duty axles. Independent suspension in the front allowed precise wheel articulation and maintained contact on uneven terrain. Solid rear axles provided durability under heavy payloads and towing requirements. Portal gear hubs increased clearance without destabilizing the center of gravity. All mechanical components were oversized and overbuilt for reliability, not aesthetics. The transfer case offered selectable high and low ranges for diverse operating conditions. Power distribution was optimized to prevent wheel slip, even in mud, snow, or rocky terrain. Engine placement balanced the chassis to maximize traction and stability. Durability. Tests ensured that the mega cruiser could survive extreme temperatures and rough ground. Its influence is felt across both civilian and military vehicle design. Heavy-duty expedition vehicles drew inspiration from its portal axle layout. Military planners noted its balance of payload mobility and reliability for tactical deployment. Industrial transporters adopted similar drivetrain and suspension philosophies. The mega cruiser proved that extremely capable off-road trucks could also carry substantial loads. Even modern Japanese and global SUVs occasionally borrow concepts first proven here. Few 1990s trucks combined mobility, utility, and mechanical durability so effectively. Its legacy remains a blueprint for modern extreme-duty 4x4s. The mega cruiser stands as a testament to Toyota's commitment to purposeful engineering. Number 5. Lada Niva. Designed during the late 1970s in the Soviet Union, the Niva was created to tackle harsh and varied terrain with minimal resources. Engineers focused on creating a compact 4x4 capable of operating reliably in rural areas and off-road conditions. Instead of prioritizing comfort or aesthetics, mechanical simplicity guided every design decision. The body was lightweight yet rigid, a unibody structure unusual for off-road vehicles at the time. Permanent four-wheel drive provided continuous traction, eliminating the need for complex engagement systems. Suspension geometry allowed for surprising articulation and stability on uneven surfaces. Ground clearance and short overhangs enabled it to conquer rocks, mud, and snow. Its small size allowed access to narrow trails and difficult paths. Ease of maintenance was crucial. Most repairs could be completed in remote locations. The Niva proved that intelligent engineering could overcome resource constraints. Its compact packaging concealed robust mechanical capability beneath a simple exterior. This approach made it one of the most efficient and practical off-road vehicles of its era. The drivetrain layout emphasized reliability above all else, featuring a straightforward yet durable transfer case. Independent front suspension enhanced wheel control while keeping production costs low. The rear live axle was simple but strong, capable of handling extreme loads. Low-weight construction allowed better fuel efficiency without compromising performance. Steering geometry was tuned for responsiveness on both road and trail. Differential locks improved traction in the most challenging conditions. Engine placement and weight distribution contributed to surprising stability. Components were designed for longevity under constant stress. Even in extreme climates, from freezing Siberian winters to muddy spring thaws, it maintained operational readiness. The mechanical simplicity reduced points of failure, ensuring dependable performance. Over the decades, minor upgrades improved safety and reliability without altering core engineering. This balance of design foresight and simplicity is what set the Niva apart from competitors. It remains a benchmark for compact 4x4 design and enduring practicality. Decades of service have proven its resilience in some of the harshest conditions on Earth. Number 4. Jeep Cherokee XJ. Introduced at a time when off-road vehicles were expected to be heavy and crude, this platform rewrote the rules. American engineers pursued efficiency, structural integrity, and everyday usability without sacrificing trail ability. Instead of relying on a traditional body-on-frame layout, a radical construction method was chosen. The goal was to reduce weight while increasing rigidity. This decision placed engineering logic ahead of industry convention. Few expected such a compact vehicle to challenge full-size trucks off-road. Market expectations underestimated its potential. What followed was a quiet shift in how utility vehicles were designed. Suddenly, strength no longer required excessive mass. Packaging efficiency became a competitive advantage. The project would influence decades of vehicle development. Its impact reached far beyond its price segment. Unibody construction formed the core of its engineering breakthrough. Structural stiffness, improved without adding unnecessary bulk. Lower curb weight translated into better handling and efficiency. Suspension tuning allowed confident behavior on pavement and dirt. Solid axles maintained articulation where it mattered most. Four-wheel drive systems were simple, durable, and accessible. Mechanical layouts prioritized serviceability over complexity. This balance allowed everyday drivers to experience real off-road capability. Traction systems proved reliable in harsh conditions. The platform tolerated modifications with ease. Engine options delivered usable torque rather than raw speed. Reliability became part of its reputation. Its influence reshaped the modern SUV landscape. Manufacturers adopted unibody construction for crossovers worldwide. Weight reduction became a core engineering goal. The idea of blending comfort with capability gained legitimacy. Designers realized that off-road credibility did not require truck proportions. Family vehicles inherited trail-ready DNA. Engineering teams studied its structural layout for future platforms. The formula proved adaptable across global markets. Decades later, its footprint remains visible. Many modern SUVs trace their lineage directly to this architecture. Few vehicles changed expectations so quietly. Among industrially influential 4x4s, its legacy is impossible to ignore. Its durability and design simplicity continue to inspire engineers today. Even modified and decades-old examples remain capable off-road. For enthusiasts and professionals alike, the Cherokee XJ stands as a milestone in 4x4 engineering. Number 3. Volvo C303. Developed during an era of Cold War neutrality, this vehicle was engineered for one purpose: absolute terrain dominance. Sweden required a transport platform that could operate in deep snow, forests, and marshland year-round. Civilian comfort was never part of the brief. Military reliability and mobility took priority over speed or appearance. Engineers focused on maintaining forward momentum under constant resistance. Every decision was guided by harsh Nordic operating conditions. Long winter deployments demanded mechanical endurance. Road networks were unreliable, forcing true off-road independence. The result was a compact yet brutally capable utility machine. Its stance alone communicated function over form. Rather than adapting an existing truck, Volvo built something purpose-driven. This approach produced one of the most underestimated 4x4 platforms ever made. Portal axles defined its engineering identity and separated it from conventional trucks. Ground clearance exceeded many larger vehicles without raising overall height. Drivetrain components were positioned to avoid damage from rocks and ice. Permanent all-wheel drive ensured continuous traction. Locking differentials allowed movement even with minimal wheel contact. Suspension geometry favored articulation over ride comfort. Torque delivery was tuned for slow, controlled progress. Axle reduction minimized stress on driveline components. Weight distribution helped maintain balance on uneven surfaces. Mechanical systems were intentionally overbuilt. Failures were rare, even under sustained load. This configuration turned extreme terrain into a manageable variable. Its impact extended far beyond Scandinavian military service. Forestry operations adopted it for off-grid access. Emergency response units relied on its consistency in snowbound regions. Portal axle concepts later appeared in high-end expedition vehicles. Modern off-road trucks still borrow clearance solutions inspired by its layout. The idea that clearance mattered more than horsepower gained traction. Durability through engineering became the benchmark. Compact size proved advantageous in confined environments. Vehicle designers revisited its balance-focused proportions decades later. Despite limited production numbers, its reputation grew steadily. Collectors now recognize its historical importance. Among industrial 4x4s, it stands as a quiet engineering milestone. Its legacy is not measured by sales numbers, but by operational success. Few vehicles have earned trust in environments where failure meant isolation. For engineers, it remains a reference point for designing machines that must survive first and impress later. Number 2. Steyerpuch, Pinzgauer. Born out of Cold War logistics demands, this machine was never meant to be ordinary transport. Austria required a vehicle that could move troops and equipment through terrain where roads were optional. Design priorities focused on mobility, balance, and mechanical survival rather than speed or comfort. Instead of scaling down a truck, engineers created an entirely new industrial platform. Mountain passes, forests, snowfields, and rocky slopes defined its testing environment. Compact proportions allowed access to narrow trails and tight operational zones. Every component was engineered with ease of repair in mind. Field service ability mattered more than showroom refinement. Weight control played a major role in maintaining off-road stability. This approach allowed consistent performance in extreme conditions. Civil defense units quickly recognized its advantages. What emerged was a vehicle that treated terrain as a design partner, not an obstacle. At the core sat a central tubular backbone chassis, protecting vital drivetrain components. Power delivery was routed high above ground hazards, instead of exposed underneath. Independent suspension on all four wheels kept traction constant on uneven surfaces. Portal axles provided exceptional clearance without increasing vehicle height. Low center of gravity ensured stability on side slopes and steep climbs. Stress loads were distributed evenly across the structure. Mechanical simplicity reduced failure points during prolonged operation. Cooling and lubrication systems were optimized for slow, high-load movement. Torque delivery favored control rather than raw acceleration. This layout minimized drivetrain shock during off-road articulation. Few vehicles of its era combined agility with such resilience. The engineering choices proved effective across decades of hard use. Long after production ended, its influence remained visible in modern utility vehicles. Expedition platforms adopted similar protected drivetrain layouts. Military designers learned that extreme mobility does not require massive size. Modular body configurations inspired adaptable vehicle architectures. Forestry and rescue vehicles borrowed its balance-focused design philosophy. Rather than overpowering terrain, it flowed across it. This mindset reshaped how off-road capability was defined. Durability became a function of intelligence, not thickness of steel alone. Engineers cited it as proof that lightweight design could survive harsh duty. Even modern 4x4s struggle to replicate its efficiency. Legacy systems still echo its mechanical logic. Among industrial off-road vehicles, few left such a lasting engineering footprint. Number 1. Mercedes-Benz Unimog. Conceived in the aftermath of World War II, the Unimog emerged as a response to a broken economy and damaged infrastructure. German engineers set out to design a single machine capable of replacing tractors, trucks, and utility vehicles. Instead of comfort or speed, the focus was placed on versatility and mechanical resilience. Its compact proportions allowed it to operate in tight agricultural fields as easily as narrow mountain roads. Unlike civilian trucks of the era, it was engineered to work continuously under extreme loads. Every design decision served a functional purpose rather than aesthetics. This made the Unimog less of a vehicle and more of a mobile tool platform. Its adaptability quickly attracted attention beyond farming. Industrial operators realized its potential in construction, forestry, and infrastructure repair. Military planners also recognized its unmatched mobility. Few vehicles have ever been designed with such a broad mission from the start. That foundation ensured the Unimog would remain relevant far beyond its original role. At the heart of its capability lies an unconventional mechanical layout. Portal axles were used to dramatically increase ground clearance without increasing overall height. This allowed the Unimog to pass over obstacles that would immobilize standard trucks. A torque tube suspension system protected drivetrain components while allowing extreme wheel movement. Permanent four-wheel drive ensured constant traction regardless of surface conditions. Differential locks further enhanced control in mud, snow, and rocky terrain. Rather than resisting terrain forces, the chassis was designed to flex with them. This reduced structural stress and improved durability over long service lives. The drivetrain sat high and protected, reducing the risk of damage in harsh environments. Engineering simplicity made field repairs possible in remote locations. These features were decades ahead of their time. Many modern off-road solutions still follow this same mechanical logic. The long-term impact of the Unimog is visible across the entire industrial vehicle world. Modern expedition trucks borrow heavily from its ground clearance philosophy. Military transport vehicles still rely on principles proven by its suspension design. Emergency services adopted it for reliability rather than speed or comfort. Its modular attachment system inspired the multi-tool approach seen in modern utility fleets. More importantly, it proved that intelligent engineering could outperform brute force. The Unimog showed that a vehicle does not need to be massive to be unstoppable. Its continued production across decades is rare in automotive history. Each generation refined the original idea rather than replacing it. Very few vehicles can claim such engineering consistency. Even today, it remains unmatched in true all-terrain versatility. That enduring relevance secures its place at the top of industrial 4x4 history. These machines weren't just vehicles, they were engineering legends that redefined capability and endurance. Their innovations live on in every modern SUV, military truck, and expedition vehicle today. If you enjoyed this deep dive into industrial 4x4 history, smash that like button, share with fellow enthusiasts, and subscribe for more epic automotive stories. Remember, true engineering isn't about looking fast, it's about lasting forever.